Hey everybody, this is Larry. This is March Friday. Actually, I don't know what day it is. March 5th. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. And you know, hope y'all are having a great day, having a weekends coming up. So enjoy yourself and hope this is just fun for you as well. If not, that's okay. Just try hard. Okay, so the question is average of levels in binary tree. Given a non-empty binary tree, return the average. Okay. So usually for these I solve it live, so if it's a little slower, I have a weird answer, that's fine. Just fast forward or whatever you like. But this one, it seems pretty straightforward. In that usually with a tree, there are only a couple of things that you ask yourself. The first one is whether there's some sort of ordering, and usually if there's an ordering, either is a binary search tree, which is not to be confused with a balanced binary search tree. But if it is a binary search tree, then you can do things that allows you to exploit that ordering and not look at every node. If there's no such ordering, then you have to look at every node anyway. And if you have to look at every node, that means that no matter what you do, it's going to be O of n time, because you'll have to look at each node once. And if that's the case, usually you have to do the height of the tree, because that's just the way it is, unless you do some like weird Morris traversal, which I don't recommend anyway. And even then, but yeah, but all that said, this is a really long-winded way of saying just do a recursion. You could you could do a breadth first search or a depth first search, whichever you like, or in order, post order, pre-order, doesn't really matter as long as you look at because every node in the tree just has a level number, and as long as you match that level number with as long as you match that level number of the node, then the average is a simple formula of sum over number, or sum over the count, right? And that's pretty much what I would say. Yeah, okay. Let's start coding. And usually I would also say that if this was on a contest, I probably solved this in about 2 minutes, because I spent a lot of time going over the concept. But yeah, but let's just do it in order, because why not? And then we'll take a node, and just keeping track of the level in this way is a little bit easier. We'll also have you could do this in a number of ways. We're just gonna have maybe 2 arrays. One array. One array. Let's just do this, and then we'll go ahead. If node is none, you return, because that's just in order. Well, that's not technically, I guess you check the left first, but I think this is a base case anyway. And then you go in order. I guess we won't be strictly speaking. You do something like this, level +1, because you go down 1. You do the same for the right, level +1, and then here is what you do. And yeah, and then there are a couple of ways to do this, but I'm going to write something like if length of total is I guess more precisely, if level is greater than equal to length of total, then we want to, actually in this case we want to do what's it called, the other one, post order. Post order, so that we can do all the creation ahead of time. And we have to change the name. That doesn't really matter. To be honest, if I do this on a contest, I might use a hash table, so it's easier. But I think this is slightly cleaner. But yeah, if this is, then you append 00, say, where this is a tuple representing the sum over n, right? So this is almost a fraction, and we just don't reduce it until later. Yeah, and then now that we have this check here, we know that total of level exists, and that is just total of level, basically the pairwise component, which is so the first one is the sum, so that's plus node.value, and then the second element, and if there's a cleaner way to do it in Python, let me know, +1, right? And then that's pretty much it. So now we do a post order from the root, level 0, and then now we have a total, which is not going to be the right answer, I know this, but we're going to kind of run on a test case to see if this is roughly right. We only have one test case anyway. Ideally, oh, I returned nothing. So, wait, what? Can only concatenate tuple. Did I mess it up? Oh yeah, whoops. Because I did a list of tuple by accident. Minor typo. I don't know if there was like an autocomplete, but that was just an accident. Okay, yeah, okay, fine. I knew that this wasn't going to be the right answer, but I didn't know that it would give me an issue with the types. But you can see that it's 3 over 1, 29 over 2, 22 over 2, which matches our presumed answer. So that means that we can just do something like, return list of was it total top over bottom, you want to say, for the average for top bottom in total, and that should be good enough. Sometimes I mistype this in Python, but that's okay. Yeah, this looks good, so let's give it a submit. Relatively confident, except for except for like maybe the case where there's no node, but I think maybe that's still, actually that should still be okay, but I should have checked it over first. But yeah, what is the complexity here, right? Well, as we said, we look at each node once, and that's the lowest you can go anyway. So so that's gonna be O of 1 per node, so O of n times total. In terms of space, because we used recursion, but you could have done it over a queue and it still has the same issue, which is that it's going to cost you O of h space, where h is the height of the tree. Of course, the question might be that, when do you choose recursion and when do you choose the queue? Well, in theory, the queue will actually use more memory, depending on the branching factor of the thing. However, core stack is more expensive, so it really depends on what the height of the tree is what I would say. But yeah, O of h space and O of n time, and that's all I have for this problem. Let me know what you think, and I will see you tomorrow. Take care of yourself, take care of others, to good health, to good mental health, and I will see you later. Bye bye.